All right, so 8.5 is sort of like a continuation of 5.1. It's going to deal with rational functions. And that's still dealing with our fractions, okay? So they start out having you do two domain problems, which I won't do because those are the same as what we did in 5.1. It's just to give you more practice with the domains. So I'm going to start where they start asking us for asymptotes and stuff. So I'm going to give us a few definitions and then we'll play with this next problem, okay? So the first definition is we call a vertical asymptote. All righty. So what a vertical asymptote is, remember vertical lines are up and down, but this is an imaginary vertical line that the graph cannot cross. So the graph cannot cross over this imaginary vertical line. They occur where the function is undefined. Because y'all, if my function is undefined, when I put an x value in there, there's no y values I'm going to get because it's undefined. So that's why this graph cannot cross over that imaginary line. Now, they come in the form of an equation. And since they're vertical lines, there'll be x equals some number. So if I was undefined at 5, then my equation for my vertical asymptote would be x equals a. So that means we find these, since they happen where the graph is undefined, we find them the same way we found our domain. We set the denominator equal to 0. So to find the vertical asymptotes, we set the denominator equal to 0. Okay? Now there's one case that can happen. If we got a factor in the numerator, which is the top of the fraction, if a factor on the numerator matches a factor in the denominator, then it cancels out that vertical asymptote and it makes a hole in the graph. So if a factor from the numerator matches a factor from the denominator, and that's why we was doing them support problems where we had to remove factors of 1 by canceling the top factor with the bottom, sort of getting you ready for this kind of stuff. But if a factor from the numerator matches a factor from the denominator, then that vertical asymptote is canceled and it makes a hole in the graph. Okay, so I'm going to try to show you a picture of what I'm talking about. Let me find one. Oh, you can't see them on the calculator, so I'll just sort of go by hand when I hit one of those and show what we're talking about. So vertical asymptotes, remember. So if we had a graph here, and say my graph, I got some point over here, A. Say my graph is undefined at A. My vertical asymptote would be a imaginary vertical line, and the graph cannot cross over that. So that means if your graph is coming in from the left side and going over, when it starts approaching that asymptote, that vertical asymptote, it's just going to keep going up towards infinity, but it's never going to cross over that imaginary line. Now, usually the other side of the asymptotes will come up from the bottom and then sort of curve. But neither side of this graph can cross over that imaginary dotted line, okay? Now, say over here at B, I had a vertical asymptote, but it got canceled because I had a factor the same as that on the top. Then what it would do, it's not going to make an asymptote there. It makes a hole in the graph. So if they're canceled, you'll get a hole. If they're not canceled, then you'll get one of these vertical asymptotes, okay? So sometimes one side will go up, one side will go down. Sometimes they both sort of come from the top. Just depends on what our equation is, okay? So that's your vertical asymptote. We also got horizontal asymptotes. So sort of similar, but a horizontal asymptote is like an imaginary horizontal line that the graph tries to approach. All right, let me see my chat. All right, Cedric, that'll work. All right, so it's an imaginary horizontal line that the graph tries to approach in either direction. So towards negative infinity and positive infinity, a graph is going to try to approach these horizontal lines. And y'all, that's sort of be like what I got up here. If I was to keep drawing this out, these two sides would try to get to these imaginary lines on that graph, okay? And it's as you go out towards infinity, they try to get closer. They never can equal that line, but they get closer and closer and closer and closer as you head towards those infinities. So these will come into form. Well, if you remember from our graphing, if it's horizontal lines, those are going to be y equals some number. So vertical is the x equals the number. Horizontal will be y equals that number. So let me show you the three cases to determine what our horizontal asymptote will be. And we look at the degree of the numerator versus the degree of the denominator. And remember, the degree is the highest exponent of each. So, first case, if the degree of the top is greater than the degree of the bottom, so if the top has bigger exponents than the bottom of your fraction, then there is no horizontal asymptote. Because y'all, if the top is bigger degree, that means it's going to be growing a whole lot faster than the bottom. And these graphs will tend to go off towards positive infinity. So there's no horizontal asymptotes on that one case. Second case, if the degree of the bottom is greater than the degree of the top, so if the bottom has bigger exponents than the top of the fraction, then it will be y equals 0. It's going to try to get to this y value of 0 as it goes towards those infinities, okay? So top bigger, no horizontal asymptote. Bottom bigger, y equals 0. What if they're the same? If degree of the top equals the degree of the bottom, then your asymptote will be y equals a over b, where a is the lead coefficient of the top and b is the lead coefficient of the bottom. Okay, and remember, the lead coefficients are the numbers in front of the variables with the highest exponents. So if I had 2x to the third on top, 3x to the third on bottom, it would be 2 over 3 because those were the numbers in front of the variables, okay? All right, so now it's just to do a lot of examples of finding asymptotes and looking at these graphs and being able to set the window on your calculator to match their graphs, okay? And we sort of practiced setting the windows when we was doing that last test. And also, let's play with these examples. So these will start around number 3 for you, okay? So this one says, list all the asymptotes then graph. So this one's like what I'm showing for number 3. Now, the graphs, they'll have 4 pictures. We don't have to hand graph these. They're going to give us 4 pictures. So what I'll do is show you how to put them on the calculator to match their pictures exactly. And then knowing our asymptotes will sort of help us make sure we're also accurate, okay? So this one, they're giving me r of x equals 5 over x squared minus 64. Now, first of all, they want the vertical asymptotes. So to find my vertical asymptotes, I'm going to set that denominator equal to 0. Okay. Now we can solve this by factoring because it is perfect squares, or you can solve it by doing the square root. This one will be pretty quick to do the square root, so I'm just going to add 64. So I get x squared equals 64, and then I'm going to do my square roots. So that'll be a plus or minus square root of 64. So the square root of x squared, those cancel, the x squared in the radical. So I get an x is a plus or minus, and then the square root of 64 would be 8. Now remember, they got to be in the form of an equation. So you're going to put x equals 8, comma, x equals -8. Okay, and they'll tell you use commas as needed on this. So there's my vertical asymptote. My horizontal asymptote, remember, looks at the degree of the top and the degree of the bottom. Well, there's no variable on top. So for this one, since there's no variable, the top is a degree 0 because there's no variable. The bottom highest exponent is 2. So the bottom is a degree 2. So this one has a higher degree in the bottom than it does on the top. So remember, we said when the bottom had a higher degree than the top, the horizontal asymptote was y equals 0. And we said that since the bottom had a higher degree than the top. So based on this, we know on our graph, over here is +8, over here's -8. I'm going to have vertical asymptotes at them two numbers. I also know as my graph goes towards infinity, one of these, it's either going to curve up or down, but it's going to try to get to that x-axis as it goes towards infinity, okay? So on their graphs for their answers, I'm going to set my window to match the graph in MATLAB. So y'all, their graphs in MATLAB are going from -16 to 16 on the x-axis, and then the y values are going from -2 to a +2. So if we set our window when we punch this in, we will get the same exact picture. And I'm actually going to show you how to make it look like a fraction so that you get it correct. So I'm going to go graph this. 5 over x squared minus 64. So we're going to share our calculator. Going to go to y equals.
Real quick.
Say again.
I have a question real quick.
Uh-huh.
So I'm following along with you on MATLAB, and I'm trying to figure out the horizontal asymptote, but I can't figure it out. Like I don't understand how we got that answer.
So on yours, what's your highest exponent on top?
0. I don't have an exponent on top.
Okay, you got just a plain number like I did.
Yes.
All right,
Sir.
what do you got on the bottom?
A 2.
Okay, so your bottom's higher, so you need to punch in y equals 0.
Yes, sir. I did that, and it still was incorrect. Do they want it in a different form?
Now what is your question actually asking? Because there's one on there I want y'all to put no on, and that's the oblique asymptote.
Oh, okay.
So if you're doing the one that says oblique, put none.
Okay. I understand now. Thank you.
Okay. Yeah, so I forgot to tell y'all that, but when you, on these problems, if it asks for an oblique asymptote, y'all are going to put none on that one. So I forgot to tell y'all that, but yeah. We don't teach those, so yeah, don't worry about those. All right, now to make this look like a fraction, I'm going to hit my green alpha button, my y equals, and enter, because that ND is my fraction notation. On top, I had a 5, and then I'm going to arrow down and put in my x squared minus 64. Now, I will say this, if you don't have, if your calculator does not have the fraction notation like I'm using, you gotta put parentheses around the numerator and denominator on these, okay? So they'll each be in their own set of parentheses on top and bottom. All right, now I don't want to graph this yet. Remember, I'm going to set my window. So I'm going to go to my window button. My X minimum was negative 16. My X max was a positive 16. And then I'm going to go down. Y minimum was negative 2. And they do this so that you can actually see the graphs good. And then Y max was 2. Now, when I graph this, remember, at that negative 8 and positive 8, the graph ain't going to cross those lines. It's going to shoot up or down, okay? So here we go with our graph. All right, so see the left side comes in, and it's going to head up towards positive infinity. Now, they're not going to draw the line here, but you can tell where there's a line sort of down through there. And then on the right side at the positive 8 is where it's doing that second one. Now, notice if you went left and left, it's drawing that thick line because it's trying to get closer to the x-axis, which is 0 for the y, but it won't never get there, okay? It'll just keep getting closer and closer as time goes on. All right, so remember that was a sort of like an upside down U. So let me show you, when you go to Math Lab, on that one, we went with A, sort of got the U shape upside down. And then over here at negative 8 and positive 8, I got my asymptotes, okay? So this one, they only did one asymptote. This one, they got the wrong directions. And then this one only did the one. Okay, so they'll sort of match what you think when you get this right here, okay? Alrighty, so let me see. Let me go to the next examples. Now, these examples I'm about to do only want me to find the vertical asymptotes. So no graphing or nothing on these. Now, they will graph a little bit later again, but for now, they just want us to find vertical asymptotes. Oh, I'm showing these is starting around 5 on mine. Might be at 4 on y'all's. So this first one, f of x equals 1 over x minus 2 squared. So then my answer box over here will be x equals blank. So since they're giving me the x equals, I don't have to put it in here. All I got to do is put in my answer. So remember, x minus 2 squared, that's the x minus 2 times the x minus 2. And then we're going to set that equal to 0. But this is a repeating factor, so I've only got to solve it one time. Because I can't have two vertical asymptotes at the same number, okay? So to solve this, all we got to do is add 2 to both sides. And I get x equals 2. So y'all, all I got to put in the box is my 2 on that, and since they gave me the x equals. All right, let's try another one. F of x equals x minus 5 over x squared plus 2x. So once again, I'm going to set that equal to 0. So I'm going to do some kind of factor into this. Now, what was the very first thing I look at when I factor? I'm looking
Something
for
common that you can take out.
exactly. And these do have something they can take out, right?
Yes, sir, the X.
Yeah, we're going to take out an x. And then let's see, that'll leave me what, an x plus 2. And there's that single x again. So we know when we set them to 0, it's still going to equal 0, okay? Even if you factor out a number and an x, it's still going to be 0 when you solve it. All right, so then we set our x plus 2 equal to 0. And y'all, I'm just going to subtract 2 on both sides. And I get my x is a -2. So I got 2 asymptotes, and this one actually has the A, B, C, D answer. A was equals 5. B was -2. C was 0, 2, and then D was 0, -2, which we got. Don't let them think you need to do the top. The top does not matter. So that's where they got that one answer with the 5 on it. But we don't care about the top. It all depends on that bottom. All right. Let me do 7 right here. 7 f of x equals x minus 3 over 1 minus x. Well, here we go. There's only one x down here, so I'm going to set 1 minus x equal to 0. And y'all, let's just solve that. So 2 ways you can solve it. You can subtract 1 and bring it over. And you'll get that negative x equals -1. And then divide them by that negative. So remember, that's like a -1 there. And that's going to make everything positive. Negative divided by negative makes that an x equal negative divided by negative makes that a +1. Now that one, the blank also had the x already, and all you did was come in and put your 1. But you got to watch and make sure they've already got the x equals there, okay? Because if they don't have that, then you got to physically put x equals 1. Right, but most of these I'm seeing are having the x equals, or they're already having like an A, B, C, D choice. All right, y'all, what's this one? Number 8. So these aren't too bad. It's doing stuff we've been doing with the domain. And most of these are, some of them are factored, some you got to factor. But y'all, this one has a 3 over x plus 5 in parentheses, x minus 1. And really, when I'm setting these equal to 0, all I'm doing is changing the signs on them, right? All right, because remember, intercepts are like zeros, and zeros always have opposite signs than the factors. So look, that 5 over here will become negative. And then here we'll add 1 and make that one positive. So let me see on number 8. They had an ABCD on the ABC on that one actually, and only one of them has our numbers right. Okay. All right, so I'm going to show you one that might be a little bit more work because these you start having to check the top if you don't know what factors are up here. So this one, x squared plus 4x minus 12 over x squared minus 2x minus 8. Now this one I probably will factor both of these because if you remember, I said if a factor from the top matches a factor on the bottom, they're going to cancel each other out. So I'm going to factor the top and the bottom just to see what I get. If none of these match the bottom, then I'll have both of these be my asymptotes when I'm done, okay? So y'all, here we go. X squared is an x and an x. Last number's negative, so you're going to have unlike signs on these factors. And you want factors of 12 that subtract to get 4. So that would be 6 and 2. So on the top, 6 and 2 are the factors that'll subtract to get 4. Larger factor 6 has the same sign as the middle. So the 6 will be positive and the 2 will be negative. And if you add those, you're going to get 6 minus 2 is 4. 6 times negative 2 is negative 12. And I'm going to do the same thing on the bottom. X squared is the x and an x. The last number, the 8, is negative, so that's going to be unlike signs. And now I need factors of 8 that subtract to get a 2. So it's going to be 4 and 2, right? Now remember, the 4 is the larger factor. It's going to have the same sign as the middle. So my 4 will be the negative and my 2 will be positive. So y'all, we had to do that to see if any would cancel, but none of these cancel because that's a plus 2 and that one's a negative 2. So those don't cancel. So that means I get to work the bottom and get both my asymptotes for my vertical, okay? So changing signs, this one's going to give me a negative 2. And over here, you're going to add 4 and get x is a positive 4. All right, and that one, they give you the answer A, B, C, D also. Now, one of them, they're going to put a y in there just to mess with you, but verticals are always x's. All right, one more vertical, and then they switch into the horizontal, okay? So here we go. G of x equals x to the third on top over, oh, what I got here? 5x to the third minus x squared minus 22x. All righty. So now I'm going to play with the bottom. Now remember the top, if you use to factor out that top would be an x times x times x. Now I'm sort of doing the bottom on the side here because it's got a lot of stuff with it. So on the side, we're going to factor this. 5x to the third minus x squared minus 22x. Now let me ask you, the very first thing you're doing in that, they all have a,
You take an X out of all of them.
I'm going to take an x out. There you go. So that'll leave you a 5x squared minus the x minus 22. Now this one's going to be a little trickier to factor. Because we got a number in front of our x squared. Now, if you're weak at factoring, you can do the quadratic formula, A, B, and C with that big formula we had. But y'all, let me show you a little what I call trial and error. So on the side, let's play with this 5x squared minus x minus 22. Well, there's only one way to multiply to get a 5. So this one will be a 5x, and this one will be a 1x. Now, they're going to have unlike signs. So one will be positive, one will be negative. Now, I don't know my signs are in the right place yet. I might have to switch them around. That's because we're doing this trial and error stuff, okay? Now, I need factors of 22. So that'll be 1 and 22 and 2 and 11. I always start with these first before I do the ones. I'm going to start with the 2 and 11. Now, what you got to do is be able to put them in here and try to be able to get what you need to make that a -1. So watch this. I'm going to put the 2 and 11 in first. Now, this and this have to add to get me a -1. Well, if you multiply that, you got a 2. That's 2x. If you multiply that, you got -55. Well, that's not going to add to get me a 1. So what I'm going to do, so that method didn't work. So I'm going to bring down my 5x again and my x. And I'm going to switch the 11 and 2 around. Let me put the 11 here and the 2 here. Now let's see what I get. That gives me 11 x's. This one gives me -10. So 11 and -10 equal +1. I need that to be negative. So guess what? That one didn't work, but now I know all I got to do is switch those signs around and make this one -11 and this one +2. Because now that gives me -11x. That gives me 10x, and those will add to get that negative. So this is called trial and error, where you take the factors of the first number and then factors of the last number, and you just put them in there in FOIL until you get what you need, okay? So not real bad. It just takes time. Now, if you want to do it without trial and error, you could do the quadratic formula, okay? And plug all those in and get your 2 answers that way. All righty, so I know this now factored into 5x minus 11 and x plus 2. So let's put that over here. X times 5x minus 11 times x plus 2. So check this out. I do have a factor that will cancel on bottom that matches the top. I got an x out here. I got 3 x's up here. This asymptote is going to cancel out with that top. So these factors cancel. Since they cancel, I'm only going to get 2 of these vertical asymptotes. I'm going to set 5x minus 11 equal to 0. And I'm going to set x plus 2 equal to 0. So y'all with me on factors canceling? I'm gonna cancel that asymptote out, okay? All right, y'all, so solving this, I'm gonna add 11. I get 5x equals 11, and then divide by my 5. So if you would have done the quadratic formula, it would have gave you 11/5 as one answer. Remember, it gives you the final answers. And then here I'm going to subtract 2 and get x is a -2. So the quadratic formula, if you'd have done that instead of factoring, would have gave you both of these answers. And y'all, this one had the box the same, where you just had to come in and put in your two asymptotes, which was 11/5, comma, -2. Okay, so I think that's the only one where anything cancels. But they like this one on our test, so get used to one of them canceling, okay? All righty, now we got to determine the horizontal asymptotes. So remember, now I'm looking at the degree of the top versus degree of the bottom. So some of these on mine are starting around 11. I got f of x equals 5x to the third plus 4 over 3x to the third minus 2. So look at this. The degree of the top equals, and then the degree of the bottom. So y'all, what is the degree of the top of this?
3.
3, there you go. And how about your bottom?
3.
All right, so that means the top equals the bottom. So remember, I said y equals a over b for that one, right? Well, a is the lead coefficient on the top. So what are y'all putting there?
3.
Oh, now that's my degree.
5.
5, there you go. Remember, lead coefficients are the numbers in front of the variable. And in the bottom,
3.
3, there you go. So let me see on this one. So on this one, they'll have the y equals part, and all you're putting in is your 5/3. So if they're equal like this one, you look at the numbers in front. Now, if there's not a number in front of the variable, what would y'all put?
A 1.
A 1, there you go. All right, y'all, let's see what I got. X squared minus 5 over 3x to the 4th plus 5. So let's look at our degrees again. So what's my degree at my top?
2.
All right, how about that bottom?
4.
Okay, so I got 2 and 4, which means the bottom is bigger than the top. So if my bottom was bigger than my top, what did we say that that was going to be? So I think that would have been option 2 when I gave y'all the 3 options. All right, so y'all listen. If the bottom is greater than the top,
Zero?
it's going to be y equals 0. There you go. And they're going to give you one of each, I'm pretty sure. So 13 f of x. Now this is a big one. X to the third minus 2x squared plus a x minus 4. All of that's over x squared minus 18. All right, so let's see the top degree and then the degree of our bottom. All right, well, let's see the degree on the top. Oh, that's a 3. The degree of the bottom is a 2. So this one, the top is greater than the bottom. So what do we say about that one? Because remember, that top is growing a whole lot quicker than that bottom is.
No horizontal asymptote?
There is no horizontal asymptote. Good job. Hey, so that's the 3 things they're going to do to you, and you're going to get one of each. One where you got to look at the numbers when they're equal. You'll have one where the bottom's bigger, and that's always going to be y equals 0. And then you'll have one where the top is bigger, and that's going to be no horizontal asymptote. And they'll have one of those where you just click the dot, okay? All righty, so now we're going to look at graphs again. So the last few, I'll do a couple of these examples, but the last few we're just going to have you find a lot of stuff and then you pick out one of the graphs. And I'll just use my calculator to graph them on and stuff, just see what we're going to get. So y'all let me switch over. So for these examples, they want us to find the domain. And we're going to find the domain by setting the bottom equal to 0. Then any asymptotes, so horizontal or vertical, the x and y intercepts. I'm going to show y'all how to do that. And then graph. So then choose the graph. Alrighty. So this first one, y'all, they're giving me, so this would be like my 14. They're giving me f of x equals 3x plus 3 over x. Now, the domain, they'll have an ABC answer, but they are in interval notation. So I'm going to work on my domain first. So remember, to find the domain, we set the denominator equal to 0. So my denominator is x, and I'm going to set x equal to 0. So that means the only number I got to kick out of my domain is a 0. So that'll go from negative infinity to 0, union around our 0, and then head off towards positive infinity. So we would choose the choice that had the union going around 0. All right, next it says x-intercepts. So to find the x-intercept, we set the numerator equal to 0. So now we set the top equal to 0 to find x-intercepts. So I'm going to set my 3x plus 3 equal to 0. and then I'm going to solve it for the x. So here we would subtract 3. And I get my 3x equals -3. And then divide by 3. So that x equals -1. But remember, x-intercept's got to look like a point. So the x will be -1 and the y will be 0. All right, so you got to put them in parentheses for the x-intercept and the y-intercept. So to find the y-intercept next, we find f of 0. We make all the x's 0 and see what we get. So for this one, f of 0 would be 3 times 0 plus 3 divided by 0. Can I do that? Well, y'all look what's in the bottom of my fraction. That's a 0. That means this is undefined. Since this is undefined, that means that there is no y-intercept. Well, that makes sense. If it's kicking out that 0, then there's no way I can have any values on the y-intercept, because that's where x is 0 at. So it does not cross the y-intercept. So it's going to do those asymptotes on it, okay? All righty, y'all, let me see what it's saying. Okay, so I'm doing my asymptotes next. So my vertical asymptote. Well, my vertical asymptote is when I set the bottom equal to 0. So that's going to give me x equals 0. So that's why I couldn't have a y-intercept, because there's a vertical asymptote sitting right there. Now, horizontal asymptote. Well, from a horizontal asymptote, look at that. What's the degree of the top? Remember, since you don't see an exponent there, it is a 1. What's the degree of the bottom? It's a 1. So my horizontal asymptote will be y equals, well, remember, on top you got a 3. On bottom you got a 1. Because since they're equal degrees, I'm looking at the lead coefficients. And this is one where you got to remember that there is a 1 in front of that x. But yo, y over 3 over 1 just gives me what? Y equals 3. So my vertical was 0. My horizontal is 3. That means on this graph, at x equals 0 right here is a dotted line going up. Graph will not cross that. Now I know up here at 3, eventually my graph is going to try to approach that 3 horizontal line as we head out towards our infinities. I also know we had an x-intercept up here at -1. So over here at -1, my graph is crossing that point right there. Okay. All right, so they're using the window they're using is -10 and all that. So my window will go from -10 to 10 for my x-min and x-max. And then they use -10 for y-min and 10 for y-max. So let's see, we know it's going through this point, but we don't know, is it coming down that way Well, that's really the only way it can go, right? Because it's not going to cross that asymptote, so it should come down like that. But let's see if it is. Woo, so let's go graph that. Easiest way to look. So go to y equals. I'm going to clear that out. I'm going to hit alpha, the green button, and my y equals to get my fraction again. ND, enter. And on top of this one was a 3x plus 3. On bottom was just the x. Now, let me go to my window. And now, since these are going back to -10 and 10, instead of physically putting them in like that, you could go to zoom number 6, and that'll put it back as a 10 by 10 graph. All right, so y'all see, you can't see the horizontal asymptote coming across, but if you go up to 3 on the y-axis, that's about what that thing's trying to head towards to out there. And then look, it's crossing the x-axis at that -1, like we said, and then the vertical asymptote along that y-axis. So, all right, so I'm just sort of drawing what it looks like on there. So this side sort of came down that 3 and then went down, and the other side comes from the top, tries to get to the 3, but it never gets there. So they'll have your choices. So I put an X on it. This was mine, where it's coming down, and then the top right's going over. Okay. So they try to look, this is 3 here for those horizontals. And then this one, they put it -3, it looks like. And then this one, they put over here at 3, making you think that the denominator gave you the, that the top gave you that one. But once you graph them, look at their graphs, -10, 10, -10, 10, and we'll get exactly their picture, okay? So y'all look, these got a lot of work on these last few problems because you're having to find so much on them, okay? So I'm gonna do another one for sure. So let me see. All right, I'm gonna do one like this one. I'm showing for like 15 f of x equals x plus 3 on the top over x squared minus 9. So this one, domain first. So the domain, we set the bottom equal to 0, x squared minus 9. And y'all, this one's perfect squares. Notice there's no GCF, so the only thing you can do with two things being subtracted is the difference of perfect squares. The x squared will be an x and an x. The last number is negative, so one's positive, one's negative. And then what's the square root of 9? Well, that's 3. So that'll give you a 3 in both spots. All right, so I got to finish solving it for my domain. So y'all subtract 3 from the first one. I get x is a -3. Second one, I'll add 3 and get x equals a +3. So my domain in interval notation will be -infinity. We hit -3 first. So we union around that -3 until we hit the +3. Union around +3 till we hit infinity. So if you got two numbers to kick out of the domain, you got two unions. All right, so now looks like they want x and y intercepts. But y'all check this out. You see how you got that x plus 3 on top? And we had an x plus 3 on the bottom. That cancels out vertical asymptotes. It also cancels out that x-intercept. Since the top factor matches one of the factors on the bottom, so since the x plus 3 factor on top matches an x plus 3 factor on the bottom, there is no x-intercept. Well, y'all, it can't have an x-intercept if it's undefined at that point, okay? So since it's undefined when you solve that, it's undefined on the bottom, there's no way we can have an x-intercept at that point. So now the y-intercept. Y-intercept, I find f of 0. So f is 0, I'm putting a 0 in for all the x's. So I'm going to have 0 plus 3 over 0 squared minus 9. Well, y'all, 0 plus 3 is 3. 0 squared is 0 minus 9 is a negative 9. And that'll reduce to a negative 1/3. So the y-intercept will be 0 for the x and a negative 1/3 for the y value. All right, so on that one, oh, they'll have an answer that says there is no x-intercept, but the y-intercept is what? And then you put that in there, okay? All righty, let me see what's next. Vertical asymptote. Well, y'all look at this. Vertical asymptote, we set the bottom equal to 0 like we did on the domain. But remember, I got a factor on top that cancels one of those factors. So the x plus 3 will not be an asymptote. That's going to make a hole in the graph. So the only equation we got to worry about is the x minus 3. Remember, the x plus 3 factor canceled out. Okay? So if it cancels out that x-intercept, it's also canceling out that vertical asymptote. So the only one I got to worry about is the x minus 3. So I'm going to add 3 to both sides and get x equals 3. And on that one, they'll already have the x equals. We're going to put in our 3. All right, next was what? A horizontal asymptote. Well, let me see who's bigger. I got a degree 1 on top, a degree 2 on the bottom. So the bottom degree is greater than the top. And we said when the bottom was greater than the top, y equals 0. And they'll have the y equals. All we got to do is put in our 0. All right, then remember there was no oblique. Okay, so we're always going to put no oblique on these. I don't know why they add them on there, but there's no obliques. All right, then we got to look at the graph. So y'all, these graphs, they're going from their window will be -5 to 5 on the x's and -5 to 5 on the y values. Remember, that's x min, x max, y min, and y max. So let me show you what you're going to do. Now, if you remember, I've been showing you how to use the green alpha button and the y equals to do the fractions. But if you wanted to, you could do it like this. Put parentheses around the top and the bottom. So parentheses x plus 3, close parentheses, and then divide. Open up the parentheses again and do the x squared minus 9. So that's what I was talking about. If you don't do the alpha y equals, you got to put those tops and bottoms in parentheses. All right, now my window. I said what, -5 to 5? Go past the scale, so I ain't worried about the scale. And then -5 to 5. That x scale, the x SCL, and the y SCL, that just means how many does each tick mark mean? Are we going by ones, twos, and whatever? So I just usually keep mine on ones and then hit graph. So see, there's that only vertical asymptote, if you notice, was on the right side at the 3 we got. Notice the one over here at -3, it got canceled out. And if you want to look at the table, go to second table. If you go to that, oh, you know what, y'all? Let me fix my table set back, because remember the other day I told y'all how to find those fraction answers. So if you don't want to do all this -1.8 and stuff, go to second window to the table and make that go by 1. And then up here, instead of starting at -2.2, I'm going to start it at -2 to get it back on regular numbers being on here, okay? All righty, so now let me go back to my table. Second graph. And see how I'm getting the error at 3? That's where that asymptote is. And at -3, you still get an error, although there's not an asymptote there. It's got a hoe there, but your calculator don't show the hoe because of the pixels, okay? But it is definitely undefined at them 2 places on our domain. All righty, so let me look at that graph. So I circled it already, but you'd pick this one. Whoops, let me share my screen. You'd pick this one. Now in the answers, they will have a hoe there like it should have, okay? And then here's the regular asymptote over here at the +3. So the graph will actually show a hoe. This one, they didn't cancel it out, so that's why that one's wrong. Okay. But y'all, that's all they're going to be doing on those examples. Toward the end is having you do your y-intercepts and all that fun stuff. So now I'm going to do one more section today, and I want to do the support for 8.6. That way, Monday, we can knock out 8.6 and then start that review, okay? Now, I will say this, 8.6 support only has 4 questions. So number 1, solve, parentheses, 7t plus 3, parentheses, 4t minus 12 equals 0. So this is already factored. When they're in parentheses equal to 0, we can go straight into setting both of these factors equal to 0. So you'll have 7t plus 3 equals 0 and 4t minus 12 equals 0. Solve both of those and we'll have our 2 solutions. Okay, so here, subtract 3, divide by 7. All right, and then divide by the 7. So looks like this one, those cancel, giving me 1t. I can't simplify that, so that'll be a negative 3 over 7. Then you're going to solve this one. So you get 4t equals 12. Then divide them by 4. So that t equals 3. All right, number 2, you just had to factor and solve. So I'm not going to do that when I'm going to do a tricky one. I'm going to solve number 3, which is a 3n squared plus 16n plus 13 equal to 0. So notice there's no greatest common factor, so I'm going to go to my parentheses on this one. Now, since it's got a number in the front, I'm going to go on the side, and I'm going to do my trial and error stuff. Now, the one thing I'm happy about, all this stuff is positive. So the only way to get a 3n is a 3n times an n. Now the 13, only factors of 13 are going to be 1 and 13. So I just got to, look here, the last one's positive, so both factors will be positive. So I know they got like signs, so all I got to do is figure out where to place that 1 and 13 at. Okay, so let's see. If I put the 1 first and then the 13, let's see what we get. We get 1n, woo, and then we get 39n. So that's not it. So let's switch the 1 and the 13 around, because there's only 2 possible combinations. So let's put the 13 and then the 1. Let's see what that adds up to. That gives you 13n. That gives you 3n. And 13 and 3 add to get 16. So I know that factors into a 3n plus 13 and an n plus 1. So that's probably the way y'all learned how to factor in high school, was that trial and error stuff. Now remember, the other way you could have done it, quadratic formula, A, B, and C. But it's almost easier to do this than that big radical, okay? All right, at that point, what are you doing? You're setting both them equal to 0. And solving them. So here I'm going to subtract 13. I get 3n is a negative 13. And then we're going to divide by 3. So that cancels, giving me n is a negative 13 over 3. And then let's see here, we're going to subtract 1. And I get n is a negative 1. So it's basically doing stuff we've been doing all night, still getting into that factoring with you, okay? So y'all, I got one more. We're going to solve 4x squared minus 28 equals 0. So now when I got an x squared term like this, x squared and a number, remember, I'm going to do the square root stuff to this. So the first thing, you want the x squared term by itself, so add 28. All right, so we get our 4x squared equals 28. And before I do square roots, I'm going to divide both sides by 4. Because I want that x squared over there by itself with a 1 in front of it. So doing that, those cancel. I get my x squared equals 7. Now I can square root both sides. And this will be a plus or minus square root of 7. So y'all, the radical cancels the exponent, leaving my x. This will be a plus or minus. And y'all look at that. I can't take a square root of 7. It will not simplify. So my final answer is a plus or minus 7. So you can put square root of 7, comma, negative square root of 7, or you can use the plus or minus and then do square root of 7. All righty, so that's the 8.6 support. It was just 4 questions. And I mainly wanted to show y'all how I do number 3 by trial and error, and then how I do number 4 by square roots. Okay. Number 2, you just factor and then set them equal to 0. So let me see. I might actually do number 2 because I still got time, I guess. So let me see. And I'll make y'all do this one. Y'all are going to solve r squared minus 5r minus 14 equals 0. Now we know it's going to go into parentheses. So what I need to know, what's going at the front of both parentheses?
R.
Okay. Now, that's negative. So that means what signs would I put?
Opposite signs.
Opposite signs. All right, that's also negative. So find me factors of 14 that'll equal 5 when I subtract.
7 and 2.
7 and 2. Good job. So where are you putting your numbers, though? Who's positive and who's negative? So remember, you gave me 7 and 2. And you got to put them numbers in here in the right order so that they equal -5, okay?
You'll do plus 2 minus 7.
Perfect. Good job. All right, so you got me factored. So now we'll just set them equal to 0 and solve. And y'all, at this point, remember, all we're doing is changing signs so that I get a -2. And I'm going to get my +7. Now, that's getting us ready for our last section that I'll do Monday. I changed 8.6 to be due next week instead of this week, because that 8.4 and 8.5 are some big sections. Okay, so 8.6 is pretty quick, and we'll knock that out Monday and start our review for that next test. Now, what I'll probably do is on Monday, instead of doing, I might do one of the next sections from 9 Monday night. That way I can have Wednesday to do the total review all at once. And then y'all won't be here all night doing 2 sections that are big, okay? 9.3 is pretty quick, so we got to do it next week. So I might do it Monday with 8.6 and then review Wednesday, okay? So I'm going to play with my review and see how long it takes me. If it don't take too long, we'll do it Monday with 8.6. So all righty, y'all. So the main thing is going to be 8.5 with those asymptotes and that graphing. But remember, just put them in your calculator. Now I want to go back one more time on my calculator. remember, when you go to your table here, if it's not giving you numbers like -3, -2, -1, 0, and all that for the x's, you're going to hit second table set. You're going to have it start on any number. That can be any negative or positive number if you want. If you want to start at 0 every time, put a 0 there. But you got to come down here and change this triangle table. That's what we call delta, that triangle. And it means the changes. And we want it to change by 1, okay? The reason mine was different was because the other day, remember when I was finding that fraction on the zeros? And I had a 5 in front, so I made it a 1/5. Mine was still on that, so I don't want to go through all them numbers on my table, so change it to 1, okay? That way, now see, since I started mine at 0, it's going to start at 0 now and go 1, 2, 3. But you can still arrow up and go to the negative stuff, okay? Alrighty, so let me see. So y'all